I welcome all in today's lecture on pathology. This is my second lecture on pathology. In first lecture, I have told you about the introduction and some part of atrophy. Today, I will continue the last part of atrophy and hypertrophy. Now come to in the first lecture class on pathology, I have told you what are the causes of atrophy, starting from decreased workload, and ultimately I have told you pressure atrophy, etc. Now come to what are the types of atrophy. Types of atrophy, it is physiologic atrophy, and pathologic atrophy, Now come to physiologic atrophy. Physiologic atrophy, we can cite example of physiologic atrophy. Physiologic atrophy after birth. We know after birth, as gradually the thyroglossal duct and notochord undergo atrophy. Now come to pathologic atrophy. Pathologic atrophy, it is two types. One is local atrophy, another is generalized atrophy. It is two types. One is local atrophy. It means in this type of atrophy, a local part, not the whole body, undergo atrophy. Only a local part of body undergo atrophy. Example, atrophy in poliomyelitis. Atrophy in poliomyelitis. You know, in poliomyelitis, again we can recall the anterior horn cell undergo destruction. So, the single limb or both limb may be undergo atrophied, and this is the example of local atrophy. Generalized atrophy, in this type of atrophy, the entire body, whole body undergo atrophy, as in, it may occur as in protein energy malnutrition, and it may also occur in prolonged starvation, and also in prolonged bed rest. You know, in protein energy malnutrition, PEM, the baby undergo marasmus and kwashiorkor. You know, marasmic baby is atrophied. So this is the types. আমরা এখানে একটা কথা বলতে পারি যে prolonged starvation, একটা মানুষের যতটুকু ডেইলি খাবার দরকার সে যদি তার চেয়ে কম খাইতে পারে অভাবের কারণে, তাই সে লোকটা শুকিয়ে যায়। আমরা বলি যে তুমি শুকিয়ে গেছো, তুমি লিনথিন হয়ে গেছো, ইজ অ্যাট্রফি। আবার যদি এটা গেল গরিব মানুষের ক্ষেত্রে, যদি একটা রিচ ম্যান সে ডায়েটিং করে নিজের শরীরটাকে স্লিম রাখার জন্য অল্প অল্প করে খায়, সেও কিন্তু আলটিমেটলি শুকিয়ে যায়। তাকে যদি আমরা বলি যে তুমি শুকিয়ে গেছো, সে কিন্তু মাইন্ড করে। তাকে যদি বলা যায় তুমি স্লিম হয়েছো, সে খুব হ্যাপি। আর যদি গরিব মানুষটাকে বলা যায় তুমি স্লিম হয়েছো, সে রাগ করে, বলে আমি খাইতে পারি নাই, আমি স্লিম কিসের, আমি তো খাইতেই পারি নাই। এ হচ্ছে আমাদের কম খাওয়া নিয়ে। একটা বডিকে স্লিম ফিগার করার জন্য কম খায়, ইট ইজ নাথিং বাট অ্যাট্রফি। আর খাবার নাই জন্যই সে কম খায়, এটাও কিন্তু অ্যাট্রফি। দুটোই স্লিম, কিন্তু একজনকে বলতে হবে স্লিম, আর একজনকে বলতে হবে শুকিয়ে গেছো, নাহলে দুজনে মাইন্ড করে। জাস্ট ইট ইজ জোক। Now come to, we know atrophy means reduction of size of cell due to loss of cell substances. I have told you in the first class, that is the reduction of number of mitochondria, number of endoplasmic reticulum, the amount of cytoplasmic proteins. Now we want to know how a cell is reduced in size. That means what is the mechanism of atrophy. Now come to mechanism of atrophy. Mechanism of atrophy. Actually, it is not clearly known how cell undergo atrophy, but there are suggestions that, you know, this is the cell, this is the nucleus, cytoplasmic proteins and organelles, and it is the endoplasmic reticulum, rough and smooth endoplasmic reticulum. Suggestion is that an autophagic vacuole is formed from smooth endoplasmic reticulum. First, there is formation of autophagic vacuole from the smooth endoplasmic reticulum. Suppose this is the autophagic vacuole is formed, then the substances that will be lost from the cell is sequestered in the autophagic vacuole. So cell substances are sequestered in autophagic vacuole. Later on, lysosome discharges enzyme on the sequestered material. Then this enzyme digests the sequestered material. Then digestion of sequestered substances. Once digestion of the sequestered substances, there is loss of cell substances and reduction of cell size. I have told you the cell membrane has got elasticity. As there is loss of substances, due to its elasticity, cell undergoes shrinkage, and this is atrophy. And this is the mechanism of atrophy. Now come to, there is a term, brown atrophy. What do you mean about brown atrophy? It means the sequestered material from the cytoplasm to autophagic vacuole, sometimes some portion of the sequestered material is not digested. and this material remain as membrane bound residual bodies. These membrane bound residual bodies sometimes produce a brown discoloration, and this is called brown atrophy. What it means? It means sometimes some sequestered material like lipofuscin is not digested. And remain as membrane bound residual bodies. And produces brown discoloration of tissue. This is nothing but brown atrophy. Now we want to know actually where from this lipofuscin is derived. It is derived from the peroxidation of intracellular lipid peroxidation. Intracellular lipid peroxidation is associated with production of lipofuscin. So this is all about the atrophy. Now come to another cellular adaptation, that is hypertrophy. We can say it is reverse of atrophy. You know, reduction of size of cell is called atrophy. If the size of cell is increased, it is called hypertrophy. So increased size of cell is called hypertrophy. In case of atrophy, there is decreased number or reduction of cell substances, but in case of hypertrophy, there is increased in number of cell substances. Hypertrophy is associated with increased size of an organ. So we can compare atrophy causes decreased size of organ, hypertrophy causes increased size of an organ. Now come to cause of hypertrophy. Cause of hypertrophy. I have told you the first and foremost cause of atrophy is decreased workload. As hypertrophy is reverse of atrophy, here increased workload is the cause of hypertrophy. Increased workload of a cell. How the workload of a cell is being increased? The workload of a cell may be increased following hormonal stimulation or following mechanical resistance. So, increased workload of a cell due to either hormonal stimulation or mechanical resistance. Later I will cite the example of hormonal stimulation associated with hypertrophy and mechanical resistance associated with hypertrophy. Now come to types of hypertrophy. Before that, we want to know, I have told you atrophy may occur in the labile cell, stable cell and permanent cell. Which cell may undergo hypertrophy? Hypertrophy may occur in in labile cell, stable cell and also in permanent cell. Now come to types of hypertrophy. It is two types. One is physiologic hypertrophy, another is pathologic hypertrophy. First, the physiologic hypertrophy. And pathologic hypertrophy. First, we have to know physiologic hypertrophy. Physiologic hypertrophy means this hypertrophy physiologically occurs, and this hypertrophy is needed for the body, and there is no problem if there is hypertrophy in the body. Now come to physiologic hypertrophy. Physiologic hypertrophy. We can cite example of physiologic hypertrophy. Hypertrophy of cell of uterus and hypertrophy in female breast. Both occurs in pregnancy, during pregnancy. So in pregnancy, what is the cause of hypertrophy? The cause is hormonal stimulation. I have told you increased workload either due to hormonal stimulation or mechanical resistance. In pregnancy, there is estrogen stimulation in the uterus and also in the female breast. So these cells undergo hypertrophy. It is due to hormonal stimulation. This is physiologic hypertrophy. If there is no hypertrophy during pregnancy may not be continued. You know, and we know pregnancy is physiological condition. It is a pathological condition. So in this condition, this hypertrophy is physiologic hypertrophy. Now come to pathologic hypertrophy. Why it is called pathologic hypertrophy? We can say here the hypertrophy first or pathology first. In the organ, first there is hypertrophy. Again we can recall, hypertrophy means increased size of cell that leads to increased size of an organ. It is due to increased number of cell substances. So hypertrophy occurs first in the organ. Then this hypertrophy is followed by pathology. We know pathology means sufferings. So the hypertrophy that will associate with the sufferings, this is called pathologic hypertrophy. So example, Example, hypertrophy in deltoid muscle. Hypertrophy in deltoid muscle. Who is affected? It is usually found in blacksmith or blacksmith. Blacksmith. You know, the blacksmith means কামার, কর্মকার, কামার। আমরা জানি কামাররা এখন প্রযুক্তির যুগে অনেক কিছু ইউজ হচ্ছে, কিন্তু আমরা যখন এই প্রযুক্তির সঙ্গে অভ্যস্ত ছিলাম না, আমরা দেখি যে কামাররা এক হাত দিয়ে ভাতি টানতো, সারাদিন ভাতি টানতো, আর ডান হাত দিয়ে রডটাকে পিটাইতো। এই সারাদিন ভাতি টানতো, এই ভাতি টানতে গিয়ে তার ডেল্টয়েড মাসেলটা বেশি অ্যাক্টিভিটি হচ্ছে, ওভারলোড। দিস ওভারলোড ডিউ টু মেকানিক্যাল রেজিস্ট্যান্স। এই ওভারলোডের কারণে তার ডেল্টয়েড মাসেল হাইপারট্রফি হতো। সো দিস ইজ হাইপারট্রফি অফ ডেল্টয়েড মাসেল। হোয়াই ইট ইজ প্যাথোলজিক? If deltoid muscle, you know, deltoid muscle is skeletal muscle, it cannot multiply. It is the permanent cell. So as it can multiply, due to resistance, it undergo increase in size to overcome this resistance. এই যখন সাইজ বাড়তেই থাকে, ডেল্টয়েড মাসেল বড় হয়ে যায়। আর ডেল্টয়েড মাসেলের ব্লাড সাপ্লাই কিন্তু যা ছিল তাই রয়ে গেল। যখন ডেল্টয়েড মাসেল বড় হয়ে গেল, মোটা তাজা হয়ে গেল, তখন যখন সে তার ব্লাড সাপ্লাই কম পাচ্ছে রিলেটিভলি, প্রপোর্শনেটলি যেটুকু পাওয়ার কথা পাচ্ছে না, তখন দেখা যাবে এখানে কিছুটা হাইপোক্সিয়া ডেভেলপ করবে। আলটিমেটলি ডেল্টয়েড মাসেল ডিজেনারেশন হবে, সেখানে ফাইব্রোসিস হবে। আর ডেল্টয়েড মাসেল যদি ফাইব্রোসিস হয়, তখন সে আর এই ঘাসটা করতে পারবে না। সো ইট ইজ নাথিং বাট দি এক্সাম্পল অফ প্যাথোলজিক hypertrophy. So here hypertrophy first, pathology is followed by hypertrophy. Then hypertrophy, left ventricular hypertrophy. Left ventricular hypertrophy. You know, from the left ventricle, blood is expelled in the aorta. If anybody suffers from hypertension, sustained hypertension, for long time hypertension, you know, and you know hypertension, what is pressure? Blood pressure. It is the pressure exerted by blood on the lateral of the blood vessel. It is nothing but the hydrostatic pressure, not the osmotic pressure. A hydrostatic pressure যদি ব্লাডে বেড়ে যায়, আমরা বলি hypertension. So anybody suffering from, suppose this is the heart, suppose this is the heart, and suppose this is the left ventricle. From the left ventricle, you know, this is the aorta. If there is hypertension, what it means? Within the systemic circulation, blood pressure is increased. So if there is hypertension, systemic hypertension, left ventricle is to contract forcefully because there is mechanical resistance. So left ventricle is to contract forcefully to compensate, to overcome the resistance in the aorta given by blood pressure, hypertension. So you also know heart muscle is the permanent cell, it cannot multiply. So to overcome this resistance, the heart muscle undergo hypertrophy, and this is called left ventricular hypertrophy. You know, the myocardium or heart is supplied by coronary artery. If there is thickness due to hypertrophy of the left ventricle, it requires increased demand of blood and oxygen, but the coronary artery cannot compensate that demand. So there is chance of ischemia within the left ventricle. So left ventricular hypertrophy first, that ischemia of the left ventricular muscle is second. Ischemia is the pathology. So this is the example of pathologic hypertrophy, and this hypertrophy is also due to increased workload against the resistance. So this is all about the hypertrophy. Today this is the today up to this. Inshallah, see you later. Thank you everybody.